Hi everyone. In this video, which covers another introductory topic, we will focus our attention on simple factoring and factoring by grouping. Factoring is going to be the most important skill you will possess whenever you are using calculus. You're going to use it at all stages of the course, from the early stages of limits and all the way to the end of the course, where we'll cover curve sketching. In this section, we're going to focus on simple factoring and factoring by grouping. Now, first and foremost, what does it mean to factor? Well, when we think of factoring, we actually look for identifying and extracting elements that are common to sums or to differences found within terms. We're usually quite comfortable with the idea of distribution. So for instance, if A were to multiply the sum or the difference of B with C, it feels natural to distribute A to B as well as A to C to produce terms AB and AC, which in turn will be added or subtracted depending on what we had initially. Now, factoring is the exact reverse operation. In order to describe the process of simple factoring, we're going to examine the expression 8x cubed minus 12x squared. And we're going to follow some guiding principles that will lead us to a complete factored form. First step would be to identify the factors that form the terms of the given expression, focusing on those that are common. 8x cubed minus 12x squared can be decomposed individually. I've chosen to rewrite 8x cubed as 2 times 4 times x squared. I've also subdivided 12x squared as 3 times 4 times x squared. Of course, there are other ways to decompose each of these terms. It could have been 2 times 2 times 2 times x times x times x for the 8x cubed. Here I've obviously went for a format that helps us recognize terms that are most common. So in this case, 4s from each term and x squares from each term. If it helps, you can rearrange and highlight the common terms. I've used some color coding here to make things even more apparent. I've taken the 4 and the x squared that are common to the terms we started off with, highlighted them, and wrote them in front of the factors 2x and 3. Then we're going to use distribution in reverse, which we really call factoring, to find the decomposed or the factored version of the original expression. So here's where we were at our previous stage, with 4x squared being a common factor to both terms. It multiplies 2x in the first case and 3 in the second. So if you remember what we did earlier about the distribution versus factoring process, you would probably recognize that 4x squared is playing the role of the A. It's multiplying with B, who is 2x in this case, and 4x squared is the multiple of 3, which is playing the role of the C in the second case. Since A is a common factor, it can be extracted, leaving the difference between 2x and 3 as its multiple. Here's a slightly more complex situation where we're going to factor the expression 5x squared times y cubed plus 25 times x times y to the power 4. We're going to follow the same guiding principles. So first of all, we can decompose each of the terms in the sum in a way where we can visualize or highlight common factors. 5 and 25 have a factor of 5 in common. X squared and x have an x in common. Y cubed and y to the power 4 have y to the power 3 in common. So basically I'm comparing what appears in both the 5x squared y cubed term and the 25x y to the power 4 term, and what is appearing to be common is the 5x y cubed. So I'm separating, I'm highlighting and extracting those terms. Even better, if you can put some color, It'd be great if my 5 had some red on it as well. 5x times y cubed is therefore playing the role of the a in our reverse distribution process, and we can extract it, leaving the x plus 5y. This time we're going to rewrite the expression 4x to the minus 2 y cubed plus 8x to the minus 3 y squared as a single fraction, and we're going to factor the numerator and denominator if it's possible. So here I'm messing with your minds a little bit by including some negative exponents as well. And to make things easier, you would probably want to remove the negative exponents, or at least rewrite the terms with those negative exponents to place them as denominators, which is what they really represent. So 4y cubed over x squared minus 8y squared over x cubed is an appropriate replacement for what we started off with. If we're going to put terms together as a single fraction, the very first thing we'll need to do is to create a common denominator. So you'll notice that all I've done to the first fraction is I've multiplied by x above and below, because essentially 1 power of x is all that was missing to make the previous denominators the same. So 4x times y cubed over x cubed is now subtracting 8y squared over x cubed. Now that the denominators are common, we can regroup as one, and then we can start focusing on the common factors. At the numerator, you'll observe that 4 is a common factor of both 4 and 8, and both terms in the difference at the numerator have at least a y squared, which is why I'm highlighting my 4y squared as a common factor, which we can then extract. Factoring by grouping is a little bit different. In French, we would say double factorisation. As you'll see, factoring by grouping is involved in situations where simple factoring is repeated. Again, there are links to be made with distribution. It's harder to see because essentially we are foiling backwards, which is not as natural. Grouping is worth considering as a factoring technique when an expression is formed of 4 terms, which we'll see why in a moment. So here is a situation where grouping would be a good strategy. In the first pair of terms, AB plus AC, you'll recognize that A is acting as a common factor. In the second pair of terms being added, DB plus DC, it's now D that is a common factor. I've highlighted them with the colors. So in the first pair, we could extract A as being a common factor to both terms. And we could extract D as a common factor to the 2 terms in the last pair as well. Now here's the magic. By factoring the A and the D from the individual pairs, we are recognizing that B plus C is then appearing in both of the factored terms. So B plus C now becomes the common element that we can extract to the front, and that leaves A plus D behind. So factoring by grouping will only be successful if we get the equivalent of this B plus C appearing, which is that after grouping or after factoring the pairs, we then have a common element appearing as well. So let's factor the expression x cubed minus 3x squared plus 4x minus 12. Here there are 4 terms, so that could be a sign that grouping may work. Okay, so our first strategy is to look for common elements in each pair. So the first pair of terms have x squares in common. The last pair of terms have 4 in common, which we'll factor. So here we've extracted x squared, leaving x minus 3. We've extracted the 4, leaving the exact same x minus 3. And that's why factoring by grouping in this situation is successful, because now x minus 3 being common allows us to extract it as well, leaving x squared and plus 4 from the second pair. Here is a slightly more elaborate situation where we have, again, 4 terms with 2 variables. And we're going to try to follow the same strategies that we did previously. So first and foremost, before you want to look at grouping, you still want to focus on the possibility of simple factoring taking place. You'll notice that absolutely every term has at least one x, and every single term has at least y to the power 2. So a good first step would be to recognize xy square as being a simple factor for the entire expression, and it can be extracted. We're still leaving 4 terms within our parentheses, and here is where we're going to attempt to group. So in the first pair, 2 minus 3x, there really is just a common 1, which doesn't appear, but we can think of it as being there. In the second pair, so the difference between 4xy and 6x squared y, both terms are multiples of 2xy. So we could extract or factor 2xy from that pair. And lo and behold, we have 2 minus 3x appearing as a common element to each pair. 2 minus 3x can therefore be extracted, factored to the front, and now we have a completely factored form for our original polynomial.